Okay, lesson 82 from page 506 in the book. It's lesson 82 out of 86, so we're nearly there. Should be there by the end of the week. Well, we will be there by the end of the week. It's motion under forces. So if motion is in 2 dimensions, it's often necessary to resolve forces into components. Example, a 40 Newton force acts horizontally to the right. So there we go. If it acts here, that's 40 newtons that way. And a 30 Newton force acts vertically upwards. So using Pythagoras' theorem and trigonometry, we can find a single force, which is equivalent to these two, known as the resultant. Okay, let me just put that 40 in a different place. So it's 40 newtons that way. This is the angle. So using Pythagoras, this is the resultant here. The magnitude of R is the square root of 40 squared plus 30 squared. On your calculator, that'll come as 50. And then theta is going to be tan inverse 30 over 40, which is 36.9. Okay. We often need to reverse the process, so we can use trigonometry to resolve the resultant forces into horizontal and vertical components x and y. Okay, so we can go backwards. Look, 50 cos 36.9 is 40. So this is 50 here. That is, and this one is the 36.9. So 50 cos 36.9 degrees. And then that one there, that's going to be 50 sine 36.9 degrees. Okay, example 1. The following forces act on an object with mass 4 kilograms. Let's do that in a nice straight line. Positioned at the origin. It's 25 newtons at an angle 30 degrees. So it's 25 newtons there, 30 degrees there. P newtons at 160 degrees. We don't know what P is, but we do know that that angle is 160 degrees. And 20 newtons at 310. So we think 90, 180, 270, 310's in here. So if that's 270 there, that bit's 40, so that bit's 50 there. What I did there, look, 180, 270, 40 makes it up to 310, so it leaves 50 in that quadrant that way. And what is it? 20 newtons. Okay, so that's the diagram done. Work out the magnitude. Okay, I missed a bit off there. The effect of the forces accelerates the object from rest in the direction of the positive x-axis. So that means, this means there's no vertical motion. So basically, the vertical forces have to equal 0. So B, that's going to be 20 degrees there to make up to 180. So for part B, we've got P, that bit there, that's a P sine 20 degrees. I'll put these in red there. That bit plus that bit there has to equal that bit there, that force there. So P sine 20 plus 25 sine 30 degrees, which is this one here. That one there, that's 25 sine 30 degrees is therefore equals to 20 sine 50 degrees. So basically the upwards forces have to equals the downwards forces. Okay, so therefore P is 20 sine 50 degrees minus 25 sine 30 degrees, all divided by sine 20 degrees. And just checking it's the same as in the book. So it is, I can use their answer. So P is 8.25 newtons. Okay. Then part C. Work out how far the object travels in the first 5 seconds. So, what you're going to have, I wonder if I've got enough room here. Let's rub some of this out, about that arrow there. Let's try and put C. So the net force is mass times acceleration. I'm not going to have enough room. My questions are set up a little bit different from the book. Right, I'm just going to put an extra page in. I think I've got a new different question. I'm not going to fit it in there at all. Extra page. Right, so I'll just quickly redraw this diagram. We've got one there, one there, one there. So the horizontal forces, so we've just worked out that that's 8.25 newtons, and that was 20 degrees. Then this one was 25 newtons at 30 degrees. And this one was 20 newtons, and that was 50 degrees. Okay, so the horizontal forces, we've got 25 cos 30 degrees plus 20 cos 50 degrees. Okay, so what I've put up there is that one there from there, but also that one there as well. Okay, but then we've got to subtract this one, which is backwards, minus 8.25 cos 20 degrees equals mass, which was 4 times acceleration. So acceleration is 25 cos 30 degrees plus 20 cos 50 degrees minus 8.25 cos 20 degrees, all divided by 4. Okay, and at that acceleration equals 6.69 metres per second squared. So all that goes in your calculator. Okay. What's the question say? The magnitude of the, I've done that one, how far it travels. So I've got the acceleration. It starts off with u is 0. Because this is this question from rest, starting from rest. That means that u is 0. A is that one. T, it's 5 seconds, look. I've got T is 5. T equals 5. So we've got A, U and T. So it's going to be S equals UT plus a half AT squared. So S is going to be 0 times 5 plus a half times 6.69 times 5 squared. And that S comes up as 83.6 metres. Okay. So the next one. We have a block of mass 10 rests on a smooth horizontal plane. Just colouring in something that'll be there. Forces of 50 newtons and 20 newtons acting at 20 degrees and 40 degrees to the horizontal. Pull the block in opposite directions on the plane. Taking g is 9.8 metres per second squared, work out the acceleration of the block and the normal reaction between the block and the plane. Okay, so we've got this block, mass 10, here. Okay, and it's pulled 20 degrees and 40 degrees. So let's just get that in the right place. Imagine it pulling from there. Let's do it like that. So there's your 20 degrees. And that's 50 newtons. And the second one is 20 newtons at 40 degrees. Okay, and they pull the block in opposite directions. G is 9.8 metres per second squared. Work out the acceleration of the block and the normal reaction between the block and the plane. Right, so this is 10g downwards, that's the weight. So that's going to be the normal reaction upwards there. Okay. So what we've got net force is mass times acceleration again. So it says here at the top, we use it in terms of vectors. So that's column vectors. Okay, so the net forces, we've got, so remember it's horizontal that way, vertical that way. So we're going to have minus 20 cos 40 degrees. I'm going from left to right. And then it's going to be that way, 20 sine 40 degrees. That's that first one. And then the next one is the 10g I'll do next. So it's 0 horizontally and minus 10g vertically. And then the next one is 0 horizontally and r vertically. The next one is 50 cos 20 degrees horizontally, 50 sine 20 degrees vertically. And this is going to be mass times acceleration. Mass is 10 times acceleration. Okay. So the acceleration of the block is what we need. So acceleration, well, let's say 10a. Putting all these together, it's going to be 50 cos 20 degrees minus 20 cos 40 degrees. And then this is 50 sine 20 degrees plus 20 sine 40 degrees minus 10g plus r. Okay. Just thinking. Now, because the block is resting, let me see, I've just needed a thought there. Because the block is resting on the plane, that means that there's 0 acceleration in the vertical direction. Okay, so this bit, let me just get this right. So, right, so because it's resting on the plane, so the acceleration is vertical, is horizontal only. Okay, so we can say 50 cos 20 degrees minus 20 cos 40 degrees is 10 times the acceleration. And then when you do that, so acceleration is 50 cos 20 degrees minus 20 cos 40 degrees, all divided by 10, which is 3.17 meters per second squared. Okay, so the acceleration is only horizontal because of that rest in there. So the vertical, 50 sine 20 degrees plus 20 sine 40 degrees minus 10g, which is 98, because it's 10 times 9.8, plus r equals 0. So r is equals to 98 minus 50 sine 20 degrees minus 20 sine 40 degrees. When you run all that through your calculator, it comes up as 68 newtons. Okay, so what happens here is you get that bit, the normal reaction, and that component there, those three upwards add up to the 10g downwards. Okay, so that's so that's why the normal reaction is less than the 10g. So I've just got an email I'm checking here. Okay, nothing important. Right, example 3. So a wedge is modelled as a prism of mass 10 kilograms, the cross-section of which is an isosceles right-angled triangle. We'll start drawing this as we go along. And it's placed with its largest face on a rough horizontal surface. Get that into black. So it's right-angled, so it's like the hypotenuse. It's going to be, its mass is 10 kilograms. So it's going to be 10g downwards. A force of 60 degrees is applied to the wedge perpendicular to one of its sloping faces. Okay, 60 newtons, sorry, not 60 degrees. The normal reaction of the surface on the wedge is R, that's going to be there, and the motion is resisted by a frictional force of 0.2 R. Friction opposes motion. Okay. Work out the acceleration of the wedge. Okay. And G is 9.8. Sorry, there's all sorts of messages going on now. Okay, so what I need to do now is set the forces. Now if this is an isosceles right angle triangle, it means that that angle there is 45. That's what I was thinking about, these angles. Those are both 45 degrees. Because they've got to add up to 180, and we've got one of them is 90, and so the other two have to add up to 90. And isosceles means you've got two equal angles, so that means they've got to be both 45 degrees. Right, so looking at all these forces, so we've got this, let's start with this force here. It's made up of two there. That's going to be 45 degrees. That's the 45 degrees, and there's 90. Okay. That's because that angle there's 45 and that's 45 there. Okay, right, so let's do these forces. We've got, don't forget, horizontal that way, vertical that way. 60 cos 45, which is that one there. And we've got that one, minus 60, the 60s. You can think of the 60 on the hypotenuse there. Sine 45 degrees. That's that one there. So we've dealt with that force there. And then we've got plus, let's go to this one now, the friction, minus 0.2 R horizontally, 0 vertically, so that's that one. This one is 0 horizontally and R vertically. This one is 0 horizontally and 10G downwards, so it's minus 10G. And this is going to be, that's all the forces. Then it's mass, which is 10 times the acceleration. Now, if we assume, again, so the motion is only horizontal. So it's not going to, there's not going to be any vertical motion. Okay, so that means that the horizontal here, these ones are 10 times A. These ones are 0, because we haven't got any vertical motion. So we can say, right, cos 45 and sine 45 are both 1 over root 2. So we've got 60 times 1 over root 2 minus 0.2 R is 10A. That's the horizontal. And then the vertical, minus 60 times 1 over root 2 plus 0 plus R minus 98 is 0. And that is because the motion is horizontal only. So equation 1, equation 2. Equation 2 is going to give us that R is 98 plus 60 divided by root 2, which is 140.5 newtons. Okay, then substitute for this in equation 1. And we've got 10A is 60 divided by root 2 plus 0.2 times 140.5. And when you work all that out, I'm just checking I've got the numbers right here. 10A is 60, yep, minus. sorry, I'm just checking my signs here for this. 10a is 60, sorry, that should be a minus there, not a plus. 10a is this one here, look, 10a, 60, yeah, so it's across there. That's correct. So a is 1.43 metres per second squared. Okay, and that's what we want, the acceleration, so we've done it. Okay, example 4 now. A block of mass 5 kilograms rests on a rough horizontal surface, plane. The block then accelerates uniformly from rest, pulled at a string inclined at 60 degrees to the horizontal. The normal reaction of the plane on the block is R. So we've got 5g downwards. And the motion is resisted by a frictional force of 0.4 R. After 9 metres, so when S is 9, the velocity is 6 metres per second. And it's resting at the start, so U, the initial velocity, is 0 metres per second. G is 9.8. Let's work out the tension in the string. Okay. Right, so what we can do, we use this information I've just put in the bubble to work out the acceleration, and then we can say the net force is mass times the acceleration. Okay, so first of all we're going to find the acceleration, and then we can work out the net force, and then we can work out the T and the R if we need to. I don't think we need to work out R, but anyway, oh yeah, we will have to. Right, let's start with the acceleration first of all. V squared equals U squared plus 2AS. So therefore 6 squared, 0 squared plus 2 times A times 9. So 36 is 18A. So the acceleration is 2 metres per second squared. Okay. Now it's only going to be, the motion is going to be horizontal again. Okay, so we can say, if we look at the horizontal components, that's going to be T cos 60 degrees, and this one here is T sine 60 degrees. So horizontally we've got T cos 60 degrees minus 0.4 R is equals to mass times acceleration. Force is mass times acceleration. The mass is 5, so it's 5 times 2. Cos 60 is 1 over root 2, so T divided by root 2, and it's 0.4 R is 10. Okay. Vertically, T sine 60 degrees plus R equals 0, because there's no vertical motion. Sorry, T sine 60 degrees plus R minus 5G. Okay, so it's that upwards 1, plus that 1, which is a negative, equals 0. So sine 60 is a half, so T over 2 plus R is 5 times G. 9.8 times 5 is 49. Okay. So we've got simultaneous equations now. We need to work out T. So call this equation 1, and this equation 2. I'm going to divide equation 1, divide by 0.4. So t over 0.4 times root 2 minus r equals 10 divided by 0.4. And then if I do, call that equation 3, and if I do equation 1 plus equation 3, what you actually find, sorry, not equation 2 plus equation 3, which is this one here and this one here, they are going to cancel. So you can say t over 2 plus t over 0.4 times root 2 is 49 plus 10 over 0.4. Right, I need a calculator. This is t times a half plus 1 over 0.4 times root 2. Right, now 49 plus 10 divided by 0.4 is 74. Yep. And then I've got 0.5, which is a half, plus 1 divided by 0.4 times root 2. Just going to quick check, yeah. And then I'm going to multiply. Then I've got to divide. So t equals 74 divided by 0.5 plus 1 over 0.4 times root 2, which is my answer on my calculator. So I do 74 divided by answer, 32.6. Okay, that's yep, and that will do for that answer.